Hello folks, well today we've got another set from the gentleman who has the trucking and farming business in Leicestershire, and it's an Immaculate Rotel RVC230. Well, it's got a box, so I presume it's Immaculate, and it's been taped. House of Fraser it says on it. So we've got the instruction book there, got the mic clip with power lead, and we've got the factory original mic which we'll play with later. I'll check we've got that scanned and get the radio out of its bag. And we'll put a duster down, seeing as it's pretty immaculate. So I've had to reset the other bank of cameras. Unfortunately, we had a power failure the other day, as you will be aware, with a thunderstorm, and one of the snags here is apart from being in the middle of nowhere and getting power failures when you get thunderstorms, is the switcher defaults to NTSC when it resets. But the trouble is you can't see what it's saying because it's in NTSC. So over the years I've found that you press this button once, that button twice, that one three, and I can find my way by counting the number of clicks, and then we get a picture on the monitor. So just to show you, it's there. It's there. And in colour. So what we're going to do with this, I think we'll open it up, because with it being a Immaculate set, it could be a return, could have had mains across it. Could have had all kinds of shenanigans. We'll put the screws in a pot, so we actually put the right ones back in. It's definitely been gone in before. I can't see any shenanigans. It looks absolutely, it even smells of newish radio. It's got a slightly bent back. How can it have a slightly bent back? Is it new and dropped? Right, let's see if we've got a bit of a power tail stub. Sometimes we have. Tell you what I'll do, I'll go and get one out of stock. We buy these in, it's not one we make, unless this is one here. Oh, there's one. This is the kind of thing we buy, and it's a bit more heavy duty than they originally came with, but this is one which we keep hanging around. We'll just check this is clean. I know it's new, but it's still 40 years old, newish. Check the springiness is springy. Right, jot down the serial number. Find the pen. 111. There we go. So we'll run with our standard test mic. Just get this connected up to our specially designed to short out crocodile clips. Current limit we're going to switch on at 8 volts, just in case it hasn't been switched on recently. We're going to current limit it to 300 milliamps. These are, the power supply I have has memories. These are all set up in the memories. That's why I've got a programmable power supply. And the LED, because the trouble with liquid crystal displays is you can't see them from all angles. So we ended up having liquid crystal displays on power supplies on benches, and then I realised I couldn't always see them. So we bought power supplies with LED displays. So the move forwards with the move backwards. Here we go, 8.5 volts, 300 milliamps. We're powered up, it's on 37, pop it down to 20. The current consumption is 166 milliamps, that's fine. Go to 13.8 volts, and we're back at normal brightness, and we'll put squelch to minimum, RF gain to full. We'll have tone can be in that position, that's normal, and we can't hear anything because we're not plugged into anything. Do these have PA? Looks like they do. It's in the squelch off position. So I don't know which socket that is. I'm not going to turn it around to find out. Testing 1 2, testing 1 2. Not that one. Testing 1 2, testing 1 2. So PA works. So from this we know the meter lamp works and PA works. So we'll now put the test equipment into the extension speaker socket. It's a floating earth, so because we're only connected to the centre, we will have to pop an earth onto a suitable place. It's got the strapping thing there, which is absolutely ideal. Go back to CB. There we are. Check the tone switch works. It does. So all the switches work. I'll tick that off in a moment. Right, we will go into picture-in-picture and we will set the test set for the 3 watt scale, and we're going to transmit on channel 20. And we'll also unplug the extension speaker. And we'll just plug in the test equipment. Three watts dead, absolutely dead. So, channel 1, 3 watts exactly. Channel 40, 2.9 watts. That sounds new, doesn't it? Low power. Back to channel 20. Do the current consumption first. We're in low power, aren't we? I'll do the low power first. 100 milliwatts. That's really useful. And on full power, current consumption is 932 milliamps. Before we even go any further, I suspect we've got a dirty preset. It's got dried and corroded, 40 years in storage. We'll waggle that around so when we're ready, it will work. We'll do the VCO first, go to channel 40, get the meter, and see if we can find some volts. I'll just borrow my earth lead, put it on the prod, stick the meter on, test points resistor 4 far side, and we should have 4 volts. And I should be able to see what I'm doing. I've only got one church today, it's Sunday, I've only got one church. So, get some other things done. I did start on that region tone radiogram. I've done 2 capacitors. I'll be doing a video. We'll do it in lots of parts, otherwise you wonder where I am with it. 4.19, I'm not going to adjust that unless transmit is out, so we'll need to adjust that. So I'm going to waggle this round because you can end up with a kind of dodgy spot. I can replace it if it plays up. I want 4 volts. Especially if I can get my positive probe on that resistor. That'll do me, and on receive it's 4.2, so now we've got to adjust it, or we've had to adjust it. I may as well drop that as well. So we'll have that at just about 4. We're now on transmit, it's 3.4. It's a bit lower than I would like, so we'll carry on working on it. .96 back to receive, transmit. 3.88, still wants a bit higher. When you don't do this, you end up with channels dropping out. 4.1, 3.96, I think that'll do me. Now the checksum here is to go to channel 1 and see that it's like 1.7 to 2.3. Yeah, right. So, I mean, that might have been alright, but I think at 4.4 we're at the point where in some temperatures we may have had channels dropping off on transmit, so that's why it was done. So it was what was it, 3.4 plus 3.4 or something. It's now basically 4 plus 4. Now the test gear's not been on that long, been on 15 minutes or so. So if we go into camera 2, which should be in colour today, frequencies 2760. Oh, we do some channel 40 to 20, don't we? There we go. 2779102. We'll bring that up. And if it's a bit too high, I can always drop it later. 2779102. I think we'll bring it up to 2779. We'll do it exactly rather than slightly higher. Okay, slightly higher, 126. Check that again in an hour. 2779126. And when we key up, what does the RF meter say? It actually says 3.8, which is about where we are. So now we'll put the signal generator on, just see where we are with receive. And at the moment we've got 100 microvolts on. Let's put that in, and we'll dial in the signal generator's frequency, 2779125. That'll do. We should have exactly S9. We haven't quite. So it's actually 265. So that's a bit out. They are okay, and sockets are okay. Sounds a bit strangled. I don't know what you think. Is that because I've got no earth on the... It's because I've got no earth on the speaker, isn't it? That's why it sounds strangled, folks, but it doesn't affect the fact that the S-meter is wrong. Okay, so we'll put the SINAD meter on. Look at camera 4, see what that's got to say. And let's drop this till we get to 1 microvolt. Oh, this is good. This bloke's got all the good sets here. 27. Sorry, wrong thing. It's 0.2. Check I'm in the right mode. I am. It's 0.2. Unless the detector's out. It's 0.2. Only because it's between scales. And for 20 dB, it's 0.36. Where's this set been all my life? Right, squelch to full. Put the attenuator up on the inset picture, and we're at 1. I want to get to 100. 3, 10, 30, 100. It comes in at 100, exactly where I'd like it to be. Sensitivity wise, turn the squelch down, turn the attenuator to so it's on standby, set the squelch on the radiator threshold. Remember we parked at 0.3 of a microvolt. Switch the signal generator back on, straight in at 0.3. Wow. And all the pots work. Deviation, bet that's low. I'll have to unplug the extension speaker. Wow, it's 1.8 on this test set. I'll put it there because we're not sure. Right, and I want that to be in its central position. Right, here we go. Transmit. So we want the centre of the peak, not just the peak. I can't see what. Just can't see the monitor from this angle. When I was using the CRT monitors, I could do that, but they don't do HDMI inputs, so, and you lose too much in those converters. Right, so transmit. We can stay on the 3 watt scale for a bit. So that's definitely the peak. That's the peak. Of course the power's dropping as we're heating things up. Now where's our special tool made by Matey for us? So temporarily putting this to full. We're now on the 30 watt scale. At least none of these are melted or broken. So 3.6 watts, put that up to full, still at 3.6 watts. I'm unkeying in between so it's got a chance to cool down. It's doing 4.3. It's nice if to do a little bit more. It's easier to set. Right, so 3.4 is about our, sorry, 4.4 is about our maximum. So the idea is we turn the yellow one clockwise till we get 3.4, but we're already at 3.4, so we're going to have to turn it till it starts to move. So that's now 4.2. Then we move the green one anti-clockwise till we hit 3.8 watts, except we're going to do it to 4 watts because that's what you're entitled to. The manufacturer normally sets it to 3.8 because they have to get it through customs. So we're at 4 watts, but it was difficult to balance on this one. It's 4 watts on channel 40 and it's 4 watts on channel 1, so I have got it right. So it's 4 watts, 4 watts, 4 watts, and our current consumption, if we go back to channel 20, is now 1.197 amps. So we've gone up to what, 170 milliwatts, 170 milliamps to deliver another watt. And our low power, I have fiddled with that, we need to now set. And remembering to be on the low scale, not the high scale. There we go, 400 milliwatts. Check this the second time, 400 milliwatts. I'll come back to do the deviation. We'll just do the transmitter, sorry, the receiver. So get our connection back in. And we'll put 100 microvolts on the signal generator, and we'll look at the oscilloscope and switch to camera 3. I mean, this is so fantastic. Either something's miles out, which is causing it to be more sensitive than you'd expect, or it's another of those 1 in 1,000 sets. So we'll do the detector. Detector's out. So that's fake sensitivity. Better turn the squelch down. Right, we'll go to the SINAD meter and see whether we can bring back that sensitivity which we had in the first place. First coil. Just drop the signal a bit more than that. Actually gained a fraction there. No difference there. Sometimes you get the extra receive coil there on these, and sometimes you don't. It's nothing to do with the sensitivity, it's a bit more to do with bleed over, which these aren't that prone to anyway. I'm going to set things now so that I can see the front meter and the oscilloscope and the SINAD meter, because I can end up on the wrong peak. I wouldn't think so with this being virtually new, but they could have got it wrong and this could be a return. So I'm just going to knock up the meter sensitivity for now, just so the meter actually moves on a low signal, not that low. Right, just see. That is spot on correct as it was. That was spot on correct as it was, that's it. So now we'll look at a new SINAD reading. Let's hope we've got that sensitivity back. But I bet this was a bit garbled with the detector where it was. So, are we on the SINAD meter? We were. Let's see what we get. So don't know whether we can use the other scale. We can't. Right. So it's 0.2 microvolts, 0.195 microvolts, and for 20, .31. That's the detector's made that better. Now this might well have thrown out the squelch. I'll tell you what, we'll do the signal meter next. Put that back to 100 microvolts, which is where it should have been. There we are, bang on the S9. Remember, on amateur radio equipment, it's something like 56 microvolts for 100. Start again. On amateur radio equipment, it's 56 microvolts, something like that, 54 for S9. But we're not on amateur radio equipment, we're on CB radio equipment, FM in the UK. So we've done that. Turn the oscilloscope off, save a few watts, and we just need to set the squelch. So we'll check it. Full squelch, see whether it's still 100 microvolts. Let's put the attenuator back up. 3, 10, 30, 100. It's still exactly the same. We don't have to touch it. It's the preset just there if we did, but we don't. And we'll just check its sensitivity. Signal generator to standby. Set threshold on the radio. Signal generator back on at 0.3. Straight in. So this is an exceptional set. 0.3 microvolts. 100 microvolts. And no duff capacitors like you get in Unidens. So all that leaves us to do really is the deviation. So I'll do that right now. We'll plug it into the test set. I think it's going to be about 1.8 because that's what they tend to be out of the box. It goes. I can't show you this, but turn the extension speaker out. Wow, it's actually 2.1, but I had fiddled with the other feedy backy one. Wow, let's set off. Go back to this test set. Let's see whether this one's lying today. Well, helps if I put it on the right thing. Wow, it's reading exactly the same. So, here we are. We are done. I'm going to go for lunch and I'll be back to put it together. It says Debenhams on the box. What on earth were Debenhams doing selling CB radios? It's funny how all these people only did it for 6 months and didn't, isn't it? And then got out. It's not one of those things you can sell out of a box very well. It has to be engineered, and you've got to have real advice. I mean, even today, people saying, "Oh, I've got a plug-and-play antenna," but there has to be hard changes as to where you put it on a vehicle. So I don't see how that can be either. Of course, that's why we drill the bodies of cars for ourselves, because we want peak performance. I buy cars for me, not the next person. I knew somebody who used to keep the plastic on the seats of a new car because you got more when you traded it in. He's one of these people who changed cars every 18 months. I couldn't do with that. Never got to enjoy it. In fact, he was my organ tutor. He was a retired bank manager. I'm going back to the 1970s. Right, well, I think we'll just test the factory original mic. Doesn't smell new though, it smells of stale cardboard box. So what we'll do, we'll put the radio onto the roof area already. So we're on the Antron 99 or the Solarcon 99 or whatever kind of 99 it happens to be. Turn the test gear off and have a flick through the channels. One nano Roger, we're on low power, it's on the front on this. One nano Roger. You have no chance. Seems to be a lot of interference today. Right, so we'll go to PA and we'll plug in our speaker on the wall and we'll just remind ourselves what it sounds like. Testing 1 2 3 4 5 5 4 3 2 1 on our microphone. We'll do most of the on the air test with our microphone as we usually do these days, and then I try to change it at the 5 mile point. So will this work, or has it got a dirty switch, or is it duff? We'll find out. Same kind of coughing mic. Testing 1 2 3 4 5. Sounds absolutely great. So there we go. We'll pop that on one side. Full 4 watt output. 0.2 microvolt receive. I don't think we're going to see sets like this, you know, with the current models. I just don't think we're going to see this kind of performance. It's a bit like with the vintage audio I do. You know, I'm doing a region tone radiogram, which was 40 something pounds plus purchase tax in 1955, and I thought they were a bit of an also ran brand like Fidelity. But you know what? Yeah, the stuff isn't going to last, is it? Perhaps people like to have a new one every 2 seconds, but I don't. So there we go. The Rotel RVC230, which we'll put back to CB. Oh, there's a bit of something out there. Thanks for watching.